All right, here in this lesson we're going to go through our notes for section 1.4 in your Algebra 1 class. So what you're really going to need is you're going to need a sheet that once we cut it looks kind of like this. So when you start with it, it looks just like this. So you're going to go ahead and cut along the dotted lines, and then to get it to look like this book that we're going to use, you take this absolute value part and just put it so you can see the words, what is absolute value here, and then fold this whole thing so that your what is absolute value goes right on top of solve. So now we have this little booklet that's going to contain all of our information about absolute value. So this is what we're really going to be using here. So the first thing that we're going to be looking at is what is absolute value. Okay, so when you flip this up, today right now you're not going to need anything specific for colors, but I'm just going to use my green pen, and I just like green because it's a different color. But really, before we dive in, let's look at our learning target for today and what we're really doing. So if you look at your learning target sheet that you have, this one right down here is I can solve absolute value equations. That's kind of our big key thing, the only real thing that we're working on today. So let's get back to our little booklet here. So the first thing that we need to think about is that absolute value is the distance from zero. So that's really important to remember, that that's what absolute value is. It's just how far away from zero. So here's our example. And that's what these lines right here are. That's the absolute value lines. So I notice and I can see that 4 is inside my absolute value sign. So that means how many steps away from 0 is 4? Well, if I was to start at 0 and I was to jump, that would be 4 steps. And so you can see here on my number line, I'm always going to start at 0 and I make 4 steps to get up to 4. So this distance right here is going to be my answer. So one other thing that we can see is that I have a -4 here inside my absolute value sign. So that tells me how far away from 0 is -4. So again, if I start at 0, 1, 2, 3, 4 steps. It is 4 steps away. So this is also going to equal 4. So a big thing to remember is that the absolute value is always a step is how many steps we take, and so that can really just help us to kind of remember what we're looking at. Okay, so now let's look a little bit more. That's just what an absolute value is. So now let's look at an actual absolute value equation. So an absolute value equation is an equation, and remember I abbreviate equation as EQN. You can abbreviate whatever you need to or however you want to that you can remember. So it's an equation that includes an absolute value expression. Right? So we've talked that an expression is just a term or a number. An equation means that I have an equal sign, right? So equal sign. Okay, so for down here, here's our example. Here I'm solving for x equals 9. Well, so now I'm being asked, what are the things, what values are 9 jumps or steps away from 0? So if I want to look at my number line, I can start at 0 and jump 9 to the right, and I can jump 9 to the left, and that's going to tell me my two solutions here. So here I know that x is going to be a positive 9, because if I go from 0, 9 to the right, I end up at a positive 9, and x is also going to equal a negative 9, because if I start at 0 and I move to the left, I'm also going to end up at a negative 9 for there. Okay, so that's kind of an intro of what absolute value is. So the next thing we're really going to be doing is solving some absolute value equations. Okay, so the first example here, I've got x plus 4, and that whole thing is inside my absolute value, and that matters. Okay, so I've got that x plus 4 equals 3. So the first thing I want to do is I know that I'm going to have two different answers because I have two different directions on my number line. Okay, so I take my equation for the first time, I take my equation and I just write it as is. So x plus 4 equals 3. Okay. The second piece that I do is I change the value or the sign of this, what my absolute value equals. So what's inside my absolute value stays the same, but the sign changes over here on the answer part. Okay, so this is kind of the important change right there. So then from here I just have two equations that I can solve like I usually do. So I see I'm adding here, so to undo adding, I subtract. So I have x equals a -1 Or, right, and here's my two possibles. Again, I say I'm adding, so I subtract. X equals a negative 7. Okay, so that's the big step, is if my absolute value is all by itself, then I go ahead and I write my two equations. The first one is written just exactly as it is. The second one, I change the sign of the second piece. Okay, so here's my second example. So here something is being done to my absolute value, and then I have an absolute value. So the first step is I have to get this absolute value all by itself. So I see here that I'm multiplying. So in order to undo multiplying, I divide both sides by 3. So now I end up with the absolute value of 13 minus 2x equals 5. Well, now my absolute value is all by itself, so now I can go ahead and set up my two problems that I did here in this first example. So now I have 13 minus 2x equals 5, and 13 minus 2x equals a negative 5. And I'm going to highlight that again just to put it in my brain of that's what changes when I'm solving these absolute values. So now I'm just going to solve these problems like I would, right? So I have to undo the addition or subtraction first. So here I see I have a 13, and since there's no sign in front of this 13, I'm adding it. So to undo that, I subtract, and I always do everything to both sides, right? So now I have a negative 2x equals a negative 8, and then to undo this multiplication, I divide by a negative 2. So x equals 4. Here I have my other answer, so again, I have to undo this addition or subtraction first. So I subtract 13 from both sides. So negative 2x equals a negative 18. To undo this multiplication, I divide by a negative 2. So x equals 9. Okay, so now these are my two possibilities. These two values will, when I plug them back into my equation, will get me 15 spaces away from 0. That's what that's really asking me to do. Okay, so now let's look at this third example. Okay, so I see I'm not only multiplying, but I'm also adding or subtracting something to what's happening with my absolute value. So the first thing we need to do is kind of get rid of this addition or subtraction. We have to kind of simplify that first. So to undo, and I'm going to use actually a different color, I think. To undo the subtraction, I go ahead and I add my 7 to both sides. So now I end up with 3 times the absolute value of 4x plus 2 equals 11 plus 7 is my 18. Well, now this looks a whole lot like example number 2. Okay, so now I can go ahead and divide by 3 on both sides. So now I just end up with the absolute value of 4x plus 2 equals 6. Well, now I'm back up to what my example 1 looked like, where I just have the absolute value all by itself. So now I write my two problems. So 4x plus 2 equals 6, and 4x plus 2 equals a negative 6. And again, I'm going to highlight just to remember that's what we changed. So I first have to undo my addition. So I have 4x equals 4. And then I undo my multiplication by dividing. So x equals 1. And then on this other side, again, I undo my addition first. So 4x equals negative 8. And then I divide by 4. So x equals negative 2. So here are my two solutions. So that's one thing to note, is when we're dealing with absolute value, we're generally going to have two solutions, right? Because there's two different directions on the number line. So there are two ways that I can jump and get back to 0. So now let's look at a special case, this fourth example. Okay, and this is something, there's a vocab word that I really want you to get from here. So we're going to talk about that in a second. So here I just see, oh, I've got my absolute value plus something equals something. Oh, so I need to get my absolute value by itself. So to do that, I subtract 6 from each side. So now I end up with the absolute value of 3x plus 5 equals a negative 8. Oh, here's something strange. So here I see I have a negative on the other side, and that's once this is all by itself. I can't have that. I can't be a negative 8 jumps away. So remember, absolute value is how many jumps or how many steps, and you can't have negative steps. So something like this means there's no solution. Okay, so what we can also see is a word that I want you to understand is the word is extraneous solutions. So an extraneous solution is a solution where you'll end up solving for it, and when you plug it back into check, you'll end up with a negative or something that doesn't actually work. Okay, so it is possible when solving these absolute value equations that it doesn't actually work. So you just have to kind of keep that in mind as you go along. So now we're going to go ahead and graph our absolute value function, and we're always going to start by graphing the parent function. And that word, the parent function, is really going to come into play here a lot this semester and next semester and in the future. Okay, so here we go. Here's our parent function. So parent function just means nothing else is happening. It's the most simple form of the function that we can deal with. Okay, so when I'm given something like this, you generally want to start with your own x values. And here they gave them to us. So we're going to look at a -2, a -1, 0, 1, and 2. But if you weren't given this table, when you're told to graph something, you can always just come up with your own x values. So what we do now is we plug each of these x values into our equation, which is right here, and we come up with our answer. Okay, so here I'm going to have the absolute value of -2, which I know the absolute value of -2, which is 2 jumps away from 0. Again, the absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So now I have some points that I can go ahead and graph. So one of my points would be right here. So my x is -2, and my y value, my f of x value, is going to be 2. So from my coordinate plane, I go -2x, so which is over, and then I go up 2. So right there, I see here I have a -1 and 1. My next point is 0, 0. I have a point at 1, 1, and a point at 1, 2. So we're going to go ahead and actually graph this. Okay, and yes, we want to include arrows on the end because this is an equation, and this is a function that just continues on and on and on in both directions forever and ever. So here's our parent function, and we're going to start doing different things to this parent function, but this is just how we kind of graph our original absolute value. So now let's look at this little example, and we're going to actually graph this one. So what we can go ahead and do is, again, we can pick some points. We're going to make our little table and pick some points. For this one, I generally like to start zeros are a good place to start, especially with something like this. I'm also going to pick a number of 2 because I like to pick numbers that make everything turn into 0. Okay, so I'm going to pick a -4, a -2, 0, 2, and 4, just because I feel like it. So now we can go ahead and do that. So when I plug them in, so I end up with a -4 minus 2. So -4 minus 2 is a -6, which gives me absolute value of -6, which gives me 6. So when I plug in -2, I end up with the absolute value of -4, which gives me 4. When I plug in 0, I have the absolute value of -2, which gives me 2. When I plug in 2 here, I end up with the absolute value of 0, which is 0. And when I have 4 minus 2, I have the absolute value of 2, which is 2. So now here again I have some points that I can graph. So I can graph my -4 and 6, and then I can graph my -2 and my 4, and my 0, 2, and my 2, 0, and my 4, 2. So you'll see here what has happened to my function. So comparing these two, I've just taken this parent function that I started with and I shifted it to the right. And this is something that we'll really get into here pretty soon with different families of functions. The big thing you need to know here is when you're graphing something or you're given this equation to graph, go ahead and pick your points. Pick wherever you want to start. So there's one more thing we need to figure out how to solve in these with these absolute value equations. Okay, so there's something that was missing from this page. So in your notebook, go ahead and find the page that where you're going to glue or tape this absolute value information. And for me, it's right here. And I'm going to go ahead and label my page, right? So I know that I'm going to glue this or tape it right here at the top. So one thing we never talked about in here is solving absolute value when there's two absolute values. So let's look at what that looks like. So the example that we're going to walk through here is going to be the absolute value of x plus 5 equals the absolute value of x plus 11. So here you'll see I have an absolute value on both sides of my equal sign. Okay, and everything up here we just had a number. We do this very similarly. Okay, so we're going to have our two possible solutions in two possible ways. So the first one is I just rewrite the equation with no absolute values. So I'm going to have x plus 5 equals x plus 11. Okay, that's the first one. The second one, I leave the stuff that's in the first absolute value alone, and then I have a negative, but of the whole thing. So I'm going to go ahead and use parentheses here. Okay, so I take everything inside my second absolute value and I make it negative. So the first thing I'm going to do is use that distributive property. So I end up with x plus 5 equals a negative x minus 11. Okay, so now let's go ahead and solve these things. I'm going to keep solving this one, just because that's where I'm at. So now, right back to our previous notes, we want to get all of our variables to the same side. So I add x, and then I subtract my 5, and then I divide by 2. So x would equal a negative 8. So now here, let's look at this. So if I subtract my x from both sides, I just end up with x equals 5 equals 11. That is not a true statement. So